The polygon below represents a regular octagon. So here we have this diagram. Calculate the following angles you must show you're working. And so what we have to do here is we have to figure out the size of angle X. If we notice here, angle X is right here. And angle X is an interior angle of this regular octagon. So what we have to figure out is what is the size, or what is the measure, or what is the value of an interior angle of this regular octagon. And so in order to do that, we're going to use this formula. And the formula states that the interior angle is equal to 180 multiplied by n minus 2 all over n. Now in this case, the number of sides is 8 because we're dealing with an octagon, and we can count. This is 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 sides that we're dealing with. And with that understanding, we're going to take n and we're going to substitute it. We're going to take 8 and we're going to place it wherever we see n. So we have 8 here and we have 8 here because n is 8 because the number of sides is 8. So we substitute that. So 8 is here and 8 is here. So we have 180 multiplied by 8 minus 2 all over 8. And what is 8 minus 2? Well, 8 minus 2 is definitely 6. So we have 180 multiplied by 6 all divided by 8. And then when we do that, that's 180 multiplied by 6. 180 multiplied by 6 gives us 1080 all divided by 8. And when we divide these two, we get 135. So that means that the interior angle is 135, which means that X is equal to 135 degrees. Next, our goal is to determine the size of Y. Notice that Y is not equal to the size of the interior angle because Y is just this portion right here, right? The interior angle would be all of this, right? But Y is just a portion of the interior angle. And so we need to figure out, okay, what is angle Y, right? And so in order to do this, what we're going to do is we're going to draw diagonals, right? And that the diagonals is going to help us. And so what we have here is we have this rule, and the rule states that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. Now, n is the number of sides, and so it's going to be, in this case, 8 minus 3. So that means that each vertex of this octagon has 8 minus 3, and 8 minus 3 is 5, so it has 5 diagonals. And so that means that every vertex, if we could go at each vertex of this regular octagon and draw 5 diagonals, all right? But we are focusing on this particular vertex, and we draw 5 diagonals. This is 1, this is 2, this is 3, this is 4, and this is 5. And so those are the diagonals that we have right there. Now what we need to do is we need to figure out, okay, what is the measure or what is the size of these little itty bitty spaces right here, right? And so what we have is we have the interior angle, which is this whole thing, right? The interior angle, which is 135, and we are going to divide it by 6. Now the reason why we divide the interior angle by 6 is because this is 1, 2, 3, 4, 5, 6 spaces. So we have 135 divided by 6, and that gives us 22.5. And so that means that each of these little spaces is equal to 22.5 degrees, all right? And so what is the size of angle Y? Well, notice that angle Y accounts for 1, 2, 3 spaces. And so angle Y is going to be equal to 3 times 22.5. And so angle Y is going to be equal to 67.5. That's the size of angle Y. So angle Y is equal to 3 times 22.5, which gives us 67.5. That's the size of angle Y. Next, we need to figure out the size of angle Z. And in order to do this, we're going to draw the diagonals again. And so here is angle Z, all right? And so we need to draw the diagonals again too. help us to figure out what is the size of angle Z. Now let's draw the diagonals. So remember, at each vertex, we're able to draw 5 diagonals. So this is 1, this is 2, this is 3, this is 4, and this is 5. We do know that each one of these spaces is going to be equal to 135 divided by 6, which is 22.5. So each one of these little spaces is 22.5 degrees. But Z only accounts for 2 of those spaces. And so that means that the size of Z is going to be 2 times 22.5, and 2 times 22.5 is definitely 45. So that means that the size of angle Z is 45 degrees. And that's the answer to this question.